Good morning, everyone. I am Naresh Kumar, Professor of Chemistry, BNMU University, Madhepura. First of all, I would like to thank organizer Darshan Parishad Bihar and TP College Madhepura for inviting me to this landmark international webinar. Respected Honorable Vice Chancellor, BNMU University Madhepura, who is also chief patron of this webinar, Professor Gyananjay Dwivedi sir, and Principal TP College Madhepura, as well as patron of this webinar, Professor KP Yadav sir. Important speaker of this webinar, Dr. Kasinath Dhurke, Associate Professor, Department of Chemistry, NIT Warangal, Dr. Prakash Chandra Jha, Dean of School of Applied Material Science, Central University, Gujarat, Dr. V.D. Tripathi, Head Department of Chemistry, MK College, Darbhanga, Dr. D.N. Arul Murugan, Associate Professor, KTH Royal Institute of Technology, Stockholm, Sweden, Dr. Syamal Kishore of this webinar and General Secretary, Darshan Parishad Bihar, Dr. Sudhanshu Sekhar, convener of this webinar, who is also PRO and DR Academic, BNMU University, Madhepura, Dr. Anand Mohan Jha, Organizing Secretary of this webinar and Assistant Professor, BNMU University, Madhepura. Today, I am going to share keynote speech about sustainable chemistry for the future. I think we all agree that it is a time for change. And this is why we sit here and talk here at this landmark webinar. We know that chemistry is key determinant of science. It is a key determinant of health, food, energy, education, and a condition to an adequate standard of living as well as non-living material. It is a key for all sustainable development goals and must be now recognized and treated as such. Our life is supported and enriched by an enormous variety of chemical products that have been invented by chemists and chemical engineers and produced by chemical industry and laboratories. But at the same time, we have learned from the experience of past decade, countries are faced with environmental concerns, including the unsustainable use of non-renewable natural resources, the degradation of ecosystem, and disruption of the environmental system that support human life. The general public now expect university teachers, chemists, and chemical engineers to work to minimize and reduce adverse effect on human health and the environment associated with the production and use of chemical products. Sustainable development is one of the most frequently used terms in today's political debate. Our current understanding of sustainable development is a regulatory idea. It has been defined sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. As a consequences, all our individual and political actions should be reflected in the light of their societal, economical, and ecological sustainability. These claims concern every field of society, among them particularly chemistry and chemistry education. Both fields should reflect on how chemistry and chemistry education can contribute to more sustainability in our society today and in the future. For this reason, chemists and chemical engineers as well as chemistry teachers have a great influence on and thus bear a responsibility for protecting the global environment. To this end, new concept or approach chemical technology is needed. Sustainable chemistry is a relatively new concept and scientific area that aims to improve the efficiency with which natural resources are used to meet human needs for chemical products and services. In doing so, it can contribute to achieving a cleaner, healthier, and sustainable environment and improving the image of chemistry as a problem-solving science in society. In modern era, teachers, chemists, scientists, industrialists frequently used new chemistry like green chemistry as well as sustainable chemistry. But there is minor difference. Green chemistry has a longer history with principles established in 1990. According to the US Environmental Protection Agency, green chemistry is the design of chemical products and processes that reduce or eliminate the generation of hazardous substance. The term sustainable chemistry has been introduced more recently in 2004. Sustainable chemistry seeks to improve the efficiency with which natural resources are used to meet human needs for chemical products and services. Sustainable chemistry encompasses the designing, manufacture and use of efficient, effective, safe and more environmentally benign chemical products and processes. Sustainable chemistry stimulates innovation across all sectors to design and drugs discovery, new chemicals, multifunctional compounds, production processes, and product practices that will provide increased performance and increased value while meeting the goals of protecting and enhancing human health and the environment. Sustainable chemistry can ensure optimum efficiency in everything we do, both individually and as a society. Sustainable chemistry also means protecting and extending employment, expertise, and quality of life. One of chemistry contributes to meeting the challenge of more sustainability in the development of our society is the promotion of sustainable chemistry in research and industrial production. Under the name of green chemistry or sustainable chemistry, a lot of efforts has been undertaken to make future chemistry less poisonous and less hazardous. Green chemistry aims at making chemistry more energy efficient, at reducing waste disposal and producing innovative products with less consumption of natural resources. Alternative processes and reaction pathway are designed. New material and products are developed contributing to meet our needs today, but with taking more care of interest of future generations. Modern chemistry education is challenged by both the political aims of sustainable development of our society in general as well from the call of green chemistry strategy in chemical research and industry in particular. School chemistry education should promote competency of the young generation to become scientifically literate, This means chemistry education has to contribute to making a student capable of actively participating in society. Competency need to promote to allow a student to understand and participate in societal debate about application of chemistry and technology. One prerequisite is that a student should achieve substantial chemistry knowledge in the context of respective sustainability issues to understand the underlying developments, alternatives and dilemma. But subject matter knowledge will not be enough. The student as future citizen also needs to learn how societal debate about questions related to chemistry, industry and the environment functions, as well as development a skill to involve themselves together with other in societal process of democratic decision making. But this is only one side of the coin. Society can only decide about the alternatives of raising sustainability in chemistry related developments and business. If there are any chemistry teachers, future chemists and chemical engineers need to learn what a more resource efficient, environmentally friendly chemistry for the future might look alike. That means the idea of green chemistry, sustainable chemistry should become part of their training from the very part. Students of chemistry programs at university should be guided to the development a deep consciousness of the importance and sustainability strategy in chemistry, research and industry, and also to develop knowledge and a skill to operate them. Fields of study are using environmental issues as a context of the chemistry education, using the debate about plastics as socio-scientific issue for chemistry education, or making the analysis of the environmental impacts of chemical synthesis a part of organic chemistry course in upper secondary school. Another set of papers will be reflect the role of sustainability, usage and green chemistry or sustainable chemistry in higher education. These papers focus on both changing the curricula towards the embedding explicit lesson on sustainable development in higher chemistry and chemical engineering education, but also on how to put the principle of green chemistry into practice in higher chemistry teaching. The latter step can be achieved, for example, by incorporating alternative reagent or making technical problem from the sustainable debate a context of higher chemistry learning. By the United Nations World Decade of Education for Sustainable, which ended 2014, the ground for broader application seems to be prepared. Anyhow, working on sustainable future is an ongoing process. Concerning this, we hope that this themed issue will inform the discussion and will help to strengthen and motivate chemistry education's contribution to more sustainable future. Sustainable chemistry provides a robust framework bringing together research, development and innovation sectors from academia. Sustainable chemistry inspires a change of pace and a new mindset that society needs in order to become more sustainable, smart and inclusive. But sustainable chemistry is important. Sustainable chemistry for the future. Sustainable chemistry has huge part to play in solving society current and future challenges. Innovation from chemical sector will be essential to sustainable low carbon economy. Sustainable chemistry also has challenges to protect and extend employment, expertise and quality of life. Innovation to need to stimulate a competitive knowledge Sustainable chemistry must be problem shooter and acceptable to the society. We have to prepare good drugs which is non-infectious, no side effect, cheaper, multifunctional. It should be economically sustainable. It must address clear society needs, environmentally and sound, and economically viable, which can sustain very well both living and non-living things. Sustainable chemistry to solve global challenges. We have to select best and non-hazardous solvent which maximum product in chemistry and chemical industry. Now, being a chairman of this webinar, I would like to thanks important speaker Dr. Dhurke for providing his perspective from organic chemistry point of view and suggesting the change in status quo on unsustainable practices in chemical industry to a practical and sustainable alternatives. I also thanks to Dr. P.C. Jha for preparing great new methods to use in laboratory which are sustainable instead of current practices and providing the empirical evidences for the same. Very nice lecture given by Dr. P.C. Jha. My new speaker Dr. Murugan Sahab, which lecture was very nice and all the way from Sweden and talking to us about the modern computational alternatives during preliminary lab works, which of course is more accurate and eliminate of potential human error, which is unavoidable even with our best effort. All speakers given very nice lecture and it is a symbol of success of this webinar. Now, lastly, a lots of thanks again to all dignitary and our important speakers. Thank you. Again, thank you.